New energy and data hardware are reaching the field faster than standard degrees can update, creating a skills gap for generalists. This chart tracks the resulting salary stagnation for generalist roles compared to the exponential trajectory of specialists in the renewables and data sectors. This demand is geographically concentrated, with skill deficits driving up compensation across India, the UAE, Saudi Arabia, Australia, and Europe. Securing these premium international roles requires a shift in strategy, moving away from the broad path of a generalist and committing to a hyper-specific technical niche. But that creates a practical problem. You have limited time and resources to upskill, so you need to pick a high-growth path that actually aligns with your natural cognitive strengths. Chasing a specialty based purely on buzzwords or advertised salaries often backfires. If the day-to-day work doesn't fit your aptitude, the learning curve becomes a wall and your career stalls. To cut through the industry hype, we partnered with Technovision Academy to analyze the 3 most in-demand training programs projected for 2026. We're going to look at the exact mechanics of each role so you can diagnose which specialized path is a realistic, sustainable fit for you. Our first path is driven by major cloud computing providers and co-location operators who are aggressively expanding hyperscale data centers worldwide. This is mission-critical infrastructure. These systems are engineered for 5 nines availability, where a single second of downtime represents a catastrophic failure. To keep servers running without interruption, engineers in this field master highly specific hardware, particularly uninterruptible power supplies, and automatic or static transfer switches. This single line diagram illustrates 2N redundancy. Power flow dynamically routes around a failed component block, guaranteeing continuity. Managing this requires operational discipline. Notice the hazard radius expanding here. Strict arc flash awareness is mandatory. If you thrive in high-pressure, strict operational environments where there is zero tolerance for errors, data center systems offer a highly lucrative track. Our second path takes us outdoors to the macro grid. Integrating new renewable energy requires a rapid expansion of ultra-high voltage transmission lines. Executing grid expansions of this scale involves an end-to-end workflow that starts with raw land surveys and finishes with the physical stringing of overhead wires. The absolute industry standard for managing this process is PLS-CAD. Engineers use this software environment for complex terrain modeling, precise tower spotting, and optimizing macro routes across hundreds of miles. Looking at this 2D profile view, you calculate how the parabolic sag of the wire reacts to changing tension metrics, verifying strict ground clearances. Shifting to a single tower, you must calculate specific wind forces and weight loads pressing against the steel frames. This skill set is the primary requirement for international EPC projects, specifically for engineers who enjoy spatial macro design and blending electrical theory with physical mechanics. Our third path leaves the physical infrastructure behind and moves into the digital brain of the network, modern substation automation, and advanced digital protection systems. At the core of this network are numerical relays. These act as split-second decision-makers that detect grid faults and instantly isolate the damage to protect the larger system. A protection engineer's daily work centers on software-driven logic. You are responsible for relay logic programming, precise parameter setting, and device configuration. To make all this work, you must master the IEC 61850 protocol. It's a complex communication standard that allows these disparate devices to talk to each other across the smart grid. This logic flowchart maps the exact process you manage during commissioning. You are conducting secondary injection testing and deep fault analysis, verifying that an overcurrent detection correctly triggers an isolation command through the network. If you are an analytical thinker who wants to move into software configuration, logic troubleshooting, and grid defense, this is your niche. We've broken down the mechanics. Now you have to evaluate your own innate engineering style to decide your next move. On this decision tree, if your strongest aptitude is systems reliability and operations, your best path is hyperscale data centers. If you prefer macro-scale infrastructure and spatial design, choose PLS-CAD. If you excel at logic programming and troubleshooting, numerical relays is your fit. Aligning technical training with your existing cognitive strengths is the only sustainable way to survive the rigorous learning curves required for these elite roles. Automation and decentralized renewable energy are rewriting the industry's rules, creating massive new opportunities for engineers prepared to evolve. Investing your time in practical, industry-oriented learning right now is the most reliable way to prepare for tomorrow's engineering challenges. To master these specific domains, look to Technovision Academy for advanced electrical AI training and research. Our mission is simple: empowering engineers, powering industry.